Okay, so we'll talk a little bit about antennas and feed lines and connectors. Essentially, you got vertical and horizontal antennas, and they may be omnidirectional or directional. We talk a little bit about feed lines and then a couple connectors. Uh, in antennas, there's a theoretical antenna that's called an isotropic radiator that's kind of used as a mathematical reference, I guess. It doesn't exist in the real world, uh, but it's a way to measure other antennas relative to it. Antenna manufacturers like it because it gives them a bigger dB number when they do dB relative to an isotropic than if they did it relative to a dipole. So it's partly marketing. The main thing about an isotropic radiator is essentially a point source. So it generates a spherical radiation pattern. All other antennas are going to have some sort of compressed spherical pattern, either into like a figure eight with lobes or kind of a squashed sphere a little bit, uh, depending on the type of antenna. When we talk about verticals, probably the most common is a quarter wave vertical. It has an omnidirectional radiation pattern. It looks like a donut surrounding the vertical antenna. And depending on the height of the antenna element will determine what we call the takeoff angle of that donut and how low it is. If it's very close to the ground, that donut kind of becomes more like a dome or half a basketball. The main thing with vertical antennas, they're vertically polarized. They're omnidirectional. They tend to pick up, because they're vertically polarized, they tend to pick up more man-made noise, which tends to be vertically polarized. So they're noisier. They have a little less gain, but sometimes the omnidirectional is a great benefit. For me, with the vertical I have using FT8, I can get anywhere in the world without having to adjust anything. And that's partly because of the magic of FT8. Where
What's that now? When you say FT8, what are you referring to?
FT8 is one of the digital modes that was developed by this guy Joe Taylor, as he's a Bell Labs guy that developed software for deep space transmissions and reception. So he applied these techniques to amateur radio, and he has these different modes. It's part of a software package called WSJTX, or Weak Signal Joe Taylor X. One of the most popular ones is called FT8, which is the two guys, Frank and Taylor, that developed it. And it will pick up signals 20 to 22 dB below the noise level. I mean, it's just amazing but it does require a computer. I mean, it's basically a computer to computer type of contact.
So what you're saying is to utilize an antenna with FT8 capability, it is processed through a computer and then onto your radio. Is that what you're saying?
Right. Well, the antenna is not part of it necessarily. I mean, uh, because of the omnidirectional effect uh, with the vertical, you can, and the fact that you can decode such low level signals with FT8, you don't need as much antenna gain. So you can pick up signals as far as New Zealand and Australia. Whereas if you're trying to do, and that's
Well, I
it,
guess what
like,
I'm saying is not what my question is to if I was to look for something on the market that has an antenna that has the FT8 capability, would I need to use that in conjunction with a laptop in the configuration with my base station transceiver?
no, no, no. The FT8 is strictly between the computer and your radio.
Okay.
Okay, you have to have a radio that's capable of sending single uh, upper single sideband in data mode. Okay, it doesn't matter what antenna you use. I was just pointing out that even though the vertical is relatively low, it's probably the lowest gain antenna of the ones we're going to talk about. With a program like FT8, and if your radio supports it, uh, you can make contact all over the world.
Very slowly.
It takes 30 seconds.
Yeah, but to understand and get any information back and forth, very slow.
Well, it's like a contest. You get the call sign and you get the signal report, right?
Screw that shit.
What, contest?
Those contests are shit.
Well, I
How would you
agree.
know,
I
Robert?
agree.
Okay, say if okay, so I'm in the market obviously for a radio or for a transceiver. How do I know that that particular transceiver that I buy is compatible with, um, say, using a laptop in order to utilize FT8? How do I know that that transceiver has that capability? What am I looking for?
The data you put into it.
Well, it needs to support uh, single sideband because this is audio frequency shift keying in single sideband mode. And it's upper sideband regardless of the band. Whereas for voice, uh, if it's below 10 megahertz, you normally use lower sideband.
Okay, so if I'm looking at a transceiver and I don't see that it supports SSB, then obviously then I'm not in the
Well,
right market.
probably any amateur radio transceiver today, even
Has SSB.
a cheap, one that does HF,
Yeah.
is to do single sideband,
Okay.
except for some of the QRP cheapies, which
Well, I
may or
mean, I'm, I've looked at that ICOM 7300, and so that's kind of, the market area that I'm looking at. So I'm pretty safe. Then anything on that shelf is going to support SSB. Okay.
that'll definitely do it. Now, you can
Yep.
also run it, although there isn't much activity, on VHF and UHF and do FT8
Right.
on those bands.
Right. Okay.
Now, remember with your technician license, the only HF band you can use for voice is 10 meters. You can do CW on the
Right.
lower frequencies, but the
Right.
only voice you can use is at 10 meters.
Gotcha.
Otherwise, you're restricted to FM repeaters or
Yep.
simplex on VHF and UHF.
Okay.
So, I mean, to start off, all you really need is a cheap handy talkie.
Yep.
The 7300 I think is a great starter radio. It's basically the one recommended by Dave Kassler for his reference station for the ARRL stuff.
Yep.
FT 991 is good because it covers UHF and VHF.
I don't know why he didn't choose that one.
I mean, HF, well, it costs more.
Well,
Which
see,
one is that?
his reference station was a starter outfit. So,
Yeah.
and the 7300 is probably the most popular radio as a starter radio
Right now, yeah.
because you can get them for $1,000, $1,100 new.
Yep.
I wouldn't buy one used either.
No, no, I'm like I said, I'm looking at one right now, obviously on Amazon, and that's the one I was looking at was that I think Amazon's got that 7300 for like $1,100. But anyway, didn't mean to take you off course on that. I was just curious about FT8.
Okay.
Check Gigaparts before you buy a 7300 on Amazon, because I've noticed Gigaparts sells a lot of stuff on Amazon, but I've noticed that if you buy it from Gigaparts, it's less.
Really?
Because they're paying for I'm guessing they have to pay for the free shipping. Because if you buy
Yeah.
something at that price level, you're getting free shipping on it. On Amazon, but now when you go to Gigaparts, you're gonna pay shipping. But everything that I've bought from Gigaparts, I've looked at it on Amazon, and even with the cost of the shipping from Gigaparts, I got it less from them.
Really?
Amazon's free shipping is included in the price.
Right.
Yeah.
That's what I was getting at. But the thing about the 7300 also on Gigaparts is I've been in this a year, and I've never looked at the 7300 on Gigaparts where there was $100 instant rebate.
And well, no, exactly. Yeah,
There's usually a
that's the-
manufacturer's rebate on it for
Yeah.
100.
Yeah,
But most
there
of
is,
them-
right. And Gigaparts, you're right, because Gigaparts is showing that 7300 with the rebate right now, and they're kicking in free shipping, so it's actually below $1,000.
Yeah, so that's even better.
Oh,
Yep.
the other thing I might mention, when you pass your technician exam, I'm assuming that they're going to continue it. Gigaparts and
Yours,
QRZ have a program called Jumpstart. And for new people that got their license within 6 months can apply, and you get a fairly decent handy talkie, a year's subscription to QRZ, the RT Systems programming software, which is worth 30 bucks,
40 bucks.
for $22. I mean, you can't beat it. So
Yeah, this has got the programming software, the RT systems you talk about. Yep.
yeah,
Yep, for 40. Yeah, but it's just an add-on accessory, 40, it's like 40 bucks.
so you might check into that if they still have. They keep extending it, so I'm assuming they're going to keep doing it. Okay,
Right.
back
Got it.
to
Thank you.
Probably the most popular is the half-wave dipole, and most of the other antennas are some variation of a half-wave dipole. It's often used as a reference antenna, and we call it dB relative to a dipole, or dBd, and it's theoretically 2.15 dBi. In other words, it's almost, or it's a little over 2 dB higher gain than the isotropic radiator, which doesn't exist. You can have a normal center-fed half-wave dipole. You can off-center feed it, usually about a quarter or third of the way, or you can in-feed it. And they all give different characteristics. We'll talk about them a little bit. And then there's beam antennas, which are usually multi-element dipoles. They could be a multi-element loop, like a cubic quad.
X beam.
or a hex beam, which are dipoles. Um, and then the most popular of the beam antennas is what we call a Yagi or Yagi Uda, which is named after two Japanese guys that developed it. From my understanding, Uda, which worked for Yagi, did it, and Yagi, because he was the boss, is the one that gets named for it. We call them Yagis. I think Dr. Uda did most of the work, which is the case on a lot of these things. The people that get the credit aren't necessarily the ones that did it. That's what an isotropic radiation pattern would look like if you could actually do one.
Closest you get is a light bulb.
Yes, a light bulb. Light goes out in a almost spherical pattern. Okay, the quarter wave vertical has a vertical element that's a quarter wavelength long. So it's a single band, in this case, antenna. It makes use of, it may or may not make use of radials and a ground plane. And you actually wind up with it being a vertical dipole. You have like an image antenna, which is the other counterposing element, which is down in the ground. So all that energy is getting absorbed. You don't get much ground reflection for the vertical. At least that's my understanding.
Has a low angle takeoff.
Yes, it has a lower angle of or takeoff angle. That's one of the reasons why it's used for AM broadcasting. As far as I know, they still use vertical antennas.
Because long wires would be so long.
Oh yeah, because they're talking low, very long wavelength. So they put them up very high, and they have a lot of radials around them. They can afford 300 radials.
Right.
They're very common in mobile setups where you're doing VHF or UHF. It's going to be a little vertical antenna on top of your car, on the bumper, or whatever. Handy talkies will use a vertical antenna. It's normally a compromised one we call a rubber ducky. So it's very short and it's flexible. It's not a very good antenna, but in most of them, you can put a better antenna on and actually get one that's quarter wave. It probably increases 3 dB on your signals. They are omnidirectional and they have that kind of donut pattern depending on the height. In this chart, you can see at a half a wavelength, which for most antennas, this is the optimum height above the ground. And that's going to give you the lowest takeoff angle and the most power out into these lobes. As you get closer to the ground, this quarter wavelength, you can see how it the average takeoff angle increases and it's becoming more dome shaped. The one down here is what, 0.025. And usually you get some weird effects when you get closer to the ground. As you get higher, you start to get lobes going up in the air. And the higher you get, either the higher they are or the more of them. In this case, they're showing 3 wavelengths, and you get all these lobes all over the place. So it becomes good for short range because it's very high angle of attack. Like in this case, whatever these are, they're probably what, 60 degrees? So it'd be good for short range communications. You wouldn't get a lot of propagation. Might even be too high to refract. This is what the radiation pattern is for the quarter wave vertical when it's like a half of wavelength high. Okay, when we go to a half wave dipole, which is a horizontal antenna, typically we center feed it. So you've got two quarter wave elements that are opposing one another in this little animation. The total length of it from one end to the other is approximately a half a wavelength. Now, because it's usually made out of copper or aluminum, the velocity factor comes into effect that we talked about. So it's going to be slightly shorter than what you would calculate because the waves are traveling at a little lower speed than the speed of light. When it's up at a half a wavelength or probably higher, it looks like it's in the 72 to 74 ohm impedance range. As you lower it, the impedance drops, or if you change the angle of these elements and slope them down towards the ground, what we call like an inverted V, they get down in the 50 ohm range or even lower, depending on the height above the ground and how what the angle of slope is. I think at 45 degrees, it gets down about 50 ohms. So in that case, it hasn't changed the radiation pattern that much, and it's a good match for 50 ohm coax. This is the typical radiation pattern, like if we were at half a wavelength high. And it's a donut around the antenna, but because it's horizontal, it's rotated 90 degrees. And if we do, and this other on the left is a cross section of that donut. If we feed it off center instead of in the middle, in this case, it has a name as a Wyndham, where it's off by what?
Third.
A third?
Yeah.
Okay. It gives us a much higher impedance. So you need some kind of balun or matching unit to match it to 50 ohms, or you could use some ladder line. I think there's a 350, isn't there?
450 was the ladder line.
Yeah.
The old
I think the stuff that
old TV stuff was like
300, yeah. I think the stuff that Bob gave me, which I haven't checked, I think
this wide black.
it's black. It's
That's
probably
450.
3/4.
That's, I think it's
Well,
450.
the 450 I have is probably over an inch.
That's what I was referring to.
Yeah, well, this that he gave me is like ladder line with the holes, window line, but it's about twice as wide as 300 ohm TV. So and he didn't know what it
I've never
is,
seen it.
and I haven't checked it. I'm gonna try it one day. Anyway,
So I have a question about this one here.
okay.
Does it, okay, so like with your, dipole, typically one side of it is connected to the center conductor and the other side is connected to the
Ground.
right.
Or yeah, okay.
Go with off center. Does it matter which side is
No.
connected to the center conductor?
No.
I don't think so.
Going through a balun.
Okay.
And you could on the center fed dipole feed it with a hairpin match or delta or something to get a better match too.
Okay.
Most people don't, because even at 75 ohms, when it's up straight, your SWR is only going to be 1.5. So if it's lower or you slope it, you can get pretty good match. Okay. So the main thing, whereas the half-wave dipole is going to be resonant at one frequency. When you go to something like the off center or the Wyndham, it's going to be resonant at even harmonics.
40 meter works at, not working 20, it works at 15.
What's even? Remember, infed is
Oh, that's
all of
right.
them.
Yeah,
Infed
okay.
is all of them. So that's the main thing. It becomes a multi-band antenna just by feeding it off center. These are some of the typical radiation patterns.
That's 80 meter.
This is an 80-meter antenna, which means it's 40 meters from one end to the other. And if it's at 40 meters in height, okay, you're going to get this kind of big clover leaf pattern. If it's up at 80 meters, you get the figure 8. And you can see as you get it lower to the ground, you keep getting more and more lobes. It almost looks like this one is optimum at the wavelength and not half a wavelength. Because that would be your best pattern for directional.
Yeah.
I didn't know that. I always thought almost all of them were half wavelength for optimum.
But it's not showing you what the actual power coming out of each one is.
Well, that's true. It's all relative.
Yeah.
And I didn't do a chart, so I don't know how valid it is anyway. This is just another one showing the resonant points for a 40-meter one. And you can see and there's yellow bars, which represent the actual amateur radio bands. So you can see that it's very close to the 40-meter band, and you got a less than 2 SWR. 20 meters, it's almost one, a little less than 1.5. At 15 meters, a little over 1.5. It's really good down here at 10 meters. And usable up here at 6. So you get a lot of bands just by feeding it off center. We can go to the other extreme and feed it on the end. You still need a balun because it's going to be very high impedance, usually several thousand ohms. So you need to match it to 50 ohms with a basically matching transformer, 7 to 1 or 9 to 1.
Yeah.
The advantage is that it's resonant at all of the harmonics. So here you see the gray bars as the bands again, and it missed this one and this one because those are weird ones. But you get a lot of bands. Actually, what is this one? This is a UK chart. What would that be? B10. Something 11 megahertz.
I don't know.
All right. Pretty close on this one. So and this little narrow guy up here, so. It's even better. Sometimes it's easier to put one up because you can attach one end to a high point and then bring it down as what they call a sloper.
I'm gonna say this can vary quite a little bit based on the height of your antenna and everything, so
Oh,
this
yeah.
is a theoretical chart, not so much a real
Right.
chart.
Like Dave Castor says with antennas, everything affects everything.
Yep. The more money you have, the better it works.
And then we come to beam antennas. Like I said, the most popular is the Yagi Uda, which is a multi-element dipole. The driven element is essentially a half-wave dipole. It uses a reflector element that's back. I never have figured out exactly the optimum. I don't know if this is an eighth or quarter wave back, but it serves to reflect the signal back, so it adds to the signal coming from the driven element at a certain point and basically increases the power. And the same thing is true for what we call these driven element, the directors. And they're all passive. There's nothing connected to them, but they do reflect the signal so that it adds to the signal coming by. It gets complicated. The one thing you notice is can't quite tell from here. The reflector is a little bit longer than the driven element. All the directors become progressively shorter and spaced farther and farther apart. So the more of these directors you have, the more gain you get, and the narrower the bandwidth. But the boom becomes longer and longer. So particularly for HF, that becomes a problem. You're talking, 30, 40-foot boom. It's a big antenna. If you do it up at VHF and UHF, these are not very big. And the direction pattern tends to be primarily a single lobe in one direction along the axis of the boom, perpendicular to the driven element, right?
Perpendicular.
To the driven element, be along the boom.
Your boom, your element's this way, so it's
Right. You get a little bit of side lobes and a little bit of rear lobe. And there's some measurements for that as the front to back gain or front to side gain. You probably can get up to, I think I've seen 15, 16 dB for typical multi-element Yagis.
Yeah, but you can vary it. The front to back ratio versus the gain is not necessarily
right. You can play with the number of directors, the spacing of the directors, and the length of the directors, and change all those parameters around. Most people optimize it for high gain, minimum bandwidth, which means you basically need to put it on a tower with a rotator, or else you're only going to see a very narrow portion of the world. Again, the elevation plot, it's going to have a fairly low angle, takeoff angle, but again, it's going to be dependent on how high it is above the ground, like most of the other antennas. And this one is probably optimum at half a wavelength.
I think they're all are.
Except for that one that we couldn't explain. There's a quad antenna, and these can have the same number of elements as the Yagi. It works kind of the same way, except as instead of having dipole type elements, you have loops. So one of the loops is actually the driven element, and it's is it a full wavelength around?
No,
Half a wavelength. Half a wavelength around the loop. It has a reflector element, which is slightly larger or a little bit longer than half a wavelength around the loop. And it has a similar kind of spacing thing so that it can reflect part of the signal back so that it winds up adding to the signal coming from the driven element at a certain point. You can add more loops in front as directors, just like in a Yagi. So you can have a 6, 7, 8 element cubical quad. If you're doing it up at UHF, for instance, I'm in the process of building one, you know, it's a 3-foot boom is give me 7 elements. It's not very big, not very heavy.
You get the circular pattern radiation, not horizontal or vertical.
No,
You get circular.
no. You actually, if you feed it at the bottom, okay, you get horizontal polarization. If you feed it on the side, you get vertical.
But I didn't know. I thought this gave you
No.
circular radiation.
Now, if you fed it on the corner, you get slant polarization. And sometimes you see these at diamonds instead of squares. And in some cases, I've seen commercial ones, the smaller ones, and they're loops. I mean, round loops instead of a square loop. It's easier to build if you're making it yourself to build the square one.
And the element is isolated from the structure that holds it out there, right?
Right. They're all isolated. Yeah, these are just loops in free space.
Right. Okay.
Actually, that could be a big solid place for the reflector. You don't need a
Oh, you mean like a screen or a solid plate?
Yeah.
Yeah, could be. And actually, I've seen some Yagis where they made the reflector. It's more than just a single.
Yeah.
Can have multiples or a screen or
multiple reflectors, but that
Yeah.
gets specialized bullshit.
yeah. Careful, you're recording. Okay, we talk about polarization. And polarization is defined as the orientation of the E field or the electrostatic field with respect to Earth. You're in outer space, I guess. You can't call it either. So a horizontal antenna, like a dipole, because the waveform is current is going back and forth along the elements, the electrostatic field, which is produced perpendicular to that, okay, is also oscillating horizontally back and forth. So we call that horizontal polarization because the plane of that E field is parallel to the Earth. If we rotate this 90 degrees and make it vertical, now the E field is vertically polarized. Be perpendicular to the Earth. Now, it turns out that all these are special cases of elliptical polarization, where you can have a phase difference between the elements. So you get a pattern that rotates, and if the two elements are equal and out of phase, you get a circle. If they're not equal, you get an ellipse. If one is much, much greater than the other, then you can get vertical, horizontal, or slanted. So they're all special cases of elliptical. And it turns out from my reading that once you get into propagating waves through the ionosphere and they're refracted, they
That's it
become
anyway.
elliptically polarized after they're refracted. So it doesn't matter what you start off with, you're going to receive a elliptically polarized wave. At least that's the theory.
There's,
And there we go. So for linear, okay, everything's in the same phase, plane, and it can be horizontal or vertical or slanted. For circular, I have the same amount, okay, in both orthogonal directions. So that gives me the circular rotation that, and if they're not equal, then it becomes more of an ellipse. And we got our rainstorm. So
it's not supposed to be here until 1 o'clock.
you believe that? Okay, so now we have receivers and transmitters and antennas. We got to connect them together. And we do that with what we call feed line. This thing always seems to be in the way. In most cases, you're going to use coaxial cable because it's easier to work with. It's the most common. It comes in 50 and 75 ohm characteristic impedances. Most of the, well, I would say all amateur radio transmitters and receivers are 50 ohm impedance in and out.
As far as I know.
The TV industry uses 75 ohms. It's much cheaper cable. There's a lot of it. And in some cases, you can use that to like match a dipole. Although you still got to convert it back at some point to 50 ohms.
And UHF use 75 ohm coax because it's cheaper and it works fine.
And in some cases, a piece of 75 ohm coax, quarter wavelength long, can act as a impedance transformer and match 100 ohms to 50 ohms. But we're not going to get into that advanced stuff.
Yeah.
There's also what we call two-wire, which in the old TV stuff, we called it twin lead. It was two conductors separated about, I don't know, ½ inch, 5/8 of an inch apart. It's 300 ohm characteristic impedance. It's pretty low loss. In the amateur world, we have open wire, ladder line, and window line, which are kind of variations. Ladder line typically is two conductors separated with some spacers that may be many inches apart. And this can be, depending on the distance, can be 600 ohm or 450 ohm. There's also ladder line and window line, which is like twin lead, only separated much farther. And then there's little square holes cut in this insulation to increase the dielectric effect. So it affects the impedance. And that's why they call it window line if it's got the holes cut in it. Your typical coaxial cable is a center conductor. In most cases, it's solid. It can be stranded for the more flexible types of coax. It's harder to work with. I spent yesterday evening playing with that. You'll have some sort of dielectric. It could be solid polyethylene or some kind of foam dielectric. In some special cases, where this is hardline coax, it could be air or little plastic spiral separators, essentially an air dielectric. It will have an outer shield or two. Most of the better coax is going to have an aluminum foil shield over the dielectric, and then a copper braid on top of that, and then some protective covering. Hopefully it's UV tolerant if you're going to use it outside. In some cases, you can get what they call direct burial. So it's not only UV, but it's more water resistant. It's a tougher, very tough, because I've been using some of that. It's hard to get through that outer jacket.
One thing I recently learned is that if you happen to get a hold of coax that's got an F rating, that means it's fireproof to
Oh,
some extent. Definitely not UV proof.
yeah, even the UV stuff, I think, suffers after many years.
Yeah.
And then we have connectors. Typically, you're going to use, this is a male or a PL 259 VHF connector. They actually are good up
Actually,
to,
it was called a UHF.
they call them UHF, but it's not really UHF because it doesn't work too well or as well at 70 centimeter band. I think it tops out, starts to have effects around 300 megahertz. On the right is an N connector. That's good for several gigahertz. One of the advantages, it maintains its impedance through it better than the PL 259. This will give you a slight impedance mismatch. This one also, I've seen, and I'm not sure I totally understand it. They call this moisture resistant. I'm not sure why, but we have people that swear by them. They cost 2 to 3 to 10 times as much if you buy these. They're easy something in connectors from Times Microwave. They're $29 a piece. But if you have the $300 installation kit, it's a piece of cake. And I used it, a friend has one, and putting one of those on is easy as pie. But
Is it
it's $30 a connector and $300 for the
is the outer shell a compression type?
yes, it crimps. I don't know if they have a solder type like in PL 259s. The only ones I've seen are crimp. You do have to solder the center pin. It's separate. And that's why I ran into trouble when I tried to use the Ultraflex LMR 400 because it's a stranded large strands, and it's larger than the solid, so it wouldn't fit the pin. So I had to go to the Barryflex that I had, which is kind of a LMR 400 knockoff, but it does have direct burial coating on it, so it's a little stiffer than the Ultraflex. The PL 259 is, well, on the end connector, there's just called a male and female. There's no different number. In the other one, the male is called a PL or plug 259. The female is a socket called SO 239. And you get those in bulkhead mount, or even you can find the female as a crimp cable connector, because I use those to make current chokes that I can put in line. They were hard to find. You had to go to DX Engineering. So any questions on, oh, I didn't show any. You might run into B and C connectors on test equipment, which is a little bayonet twist lock connector. They're very convenient to use. They're usually on something like RG58 or 8X or some of the smaller coaxes to hook up to test equipment like oscilloscopes and things. For really high frequency stuff, you'll see what's called an SMA. And I don't remember what that stands for.
Small.
They are small, 1/4 inch in diameter, or maybe slightly less. It's a little screw-on connector that's 50 ohms, and they're good up to the what, probably 10 gigahertz range. The downside is you have to use some fairly small coax with them, which is high loss. So the fact that the connector is good, you're gonna, if you have any length at all, which normally you have very short pieces when you're doing that kind of stuff. But you get a lot of loss in the coax.
It's a lot for interconnecting within.
Yeah, in radios, you'll see it internally a lot. To go from a shielded box to something on the circuit board, little 6-inch pieces. Or just cases where you just need a small connector and you don't care about the frequency.
And they're low power.
Low power. Actually, it turns out the end connector is too.
Yeah.
I didn't realize that, but the guy, can't remember his name now, WHJI, that designed the Ameritron power amplifiers. Got a lot of videos about setting them up and modifying them and stuff. And one of his videos is testing connectors. And he has this test setup with a kind of a homemade high pot. And the PL259s arced over at about 3,500 volts. The end connectors at about 1,500. Because if you look, the spacing is much closer together between the center pin and the shield. So, although most people don't have a lot of power up at UHF. I think on 1,200 megahertz, I'm not sure I can put out 50 watts. I think it's more like 20 or 30.
Well, if you put out more, you use waveguide, electrons, and
All right. Well, any questions on connectors? Because that's my last slide.
Nope. Nope, that was it.
If you plan on doing any homemade cables, you'll need to invest in a connector kit. There's a fairly reasonable one that's sold by gosh,
was that connector.com? They have
no, Quicksilver Radio. It's also sold, HRO has them also, and I think it's from Quicksilver. It looks like the same thing. It comes in a little case. You get the crimping tool, you get the circumcising tool, a screwdriver, a cable cutter, something else, which is really all you need to do it. In the
frustration too.
frustration. In this one, the cutter has adjustments so that, and there's two of them. There's one for 1/2-inch cable and one for 1/4-inch cable. And you can adjust the 3 cutters, which you need to do, but it turns out that for any particular cable, you can get it all adjusted where it works fine. but it won't work fine on a different cable, even though it's approximately the same size. So in fact, the last time I was at HRO, I wound up buying a second one so I can have one set up for LMR 400 and one for a different one.
First you have one to cut the outer,
Well, this does all three at one time.
all three at one time?
Yeah.
Oh, okay.
Yeah.
Because when
And it's a
you
clip-on.
you change it,
Oh, okay.
or you,
Yeah, this
the
does all
outer
three, and it
connector
works
is-
good when you got it adjusted right for quality cable. Because sometimes the outer insulation is not the same thickness all the way around, and maybe the dielectric and stuff like that, which messes it up. But for the price, like $100 for the kit. Now, if you go the LMR route,
The crimper.
the crimper, and it has replaceable jaws.
Okay.
So you can get
Same
Uh,
crimper for
you can
half.
get jaws for power poles.
Okay.
Or for regular crimp ring terminals.
Okay.
And for other sizes of coax. I think it comes with two sets for two different sizes. And I got the extra ones and I use it all the time for power poles and regular crimp stuff. And it's just a matter of unscrewing the two things and put them in.
So far, everything that I've built up, I've just used the regular automotive type spade connectors. At some point or another, I'm gonna buy a crimper, so. I can-
Well, yeah, this is a lot nicer for those because it's a ratchet
Yeah.
and you can really squeeze them and,
Okay,
whereas the cheapy regular automotive crimp things,
right. Yeah, they're garbage.
yeah. If you want to go the professional route and get a Times microwave kit, they have special cutters
Mhm.
for each coax at, what were they? 50 or $100 a
Gotta
piece.
use two coaxes, RG8UX.
Yes,
Yep.
they work really great, but their stuff is very expensive.
Yeah.
Most popular cable you would use is the RG8X.
Yeah, I was using a lot of that, but so that I can use my power amplifier, I'm converting everything over to LMR 400 or
Lower watts.
equivalent. Well, power, 8X won't handle 1,000 watts. Not rated for it.
Not rated for it.
Mm-mm. Surprised me,
Surprised me.
because I like 8X. It's easy to use and it's nice and flexible.
Yeah,
I can still use it in some places where we don't have the power, like out of the
you have a good standing
Transceiver.
wave ratio, you're not gonna get high voltage.
in what?
If you have a very good standing wave ratio, you won't get high voltage,
Well,
because it's only 50 ohms and 1,000 watts, and 50 ohms is only gonna be, what, 200 volts most?
E squared over R,
Yeah,
so
100,
P is equal to E squared over R.
right. I don't have a calculator. 100, that's 10,000,
So E is going to be
that's 2 kW.
the square root of P times R. So 50 times 1,000 for 1,000 watts. What's the square root of 50,000?
Is that on the test? I have to, I'm taking notes, Robert. Go ahead. You're
Not on
recording
not on the technician test.
this.
The E squared R is
E squared R, yeah,
power is equal to E squared over R.
Yep.
You got to remember that one.
yep. Extra.
I think
50 times,
that might show up on the general.
yeah, 50 times 100 volts is 5,000 watts.
50 amps,
50 ohms,
50 ohms.
right? 100 watt or 100 volts, you get 2 amps, right? times 100 is 200
100
watts.
watts into 50 ohms is 70.7 volts RMS.
Okay.
So multiply that by 2 times the square root of 2.
4.1. Point.
So that's how many volts peak to peak it is for 100 watts.
Oh, I forgot.
Yeah.
DC wise.
Yeah.
Okay.
There's a difference between RMS and peak to peak. You need to know that too.
Okay.
Not doing this all the time. You sort of get a little things.
Oh yeah. Teaching class helps refresh,
Okay. That's why I'm coming up
Yeah.
here.
Yeah, it does.
especially when I started taking the studying for the amateur exams. And boy, for the extra, I had to go back to stuff I learned in college 60 years ago
Yes,
that I forgot and never used.
60
exactly.
in college?
Yeah,
You're over 80?
I'll be 80 in February.
You're not there yet. It's only 59. So
I was in college 60 years ago.
Wow.
all right.
That's about when Kennedy got shot.
Yeah. Yeah.
I remember that. I was in
1960.
the engineering building at the common room.
I was in bed.
Oh,
What campus? Where'd you go to school, Robert?
University of Kentucky, Lexington.
Gotcha.
Where are you at?
I'm in Panama City right now, but I'm from Michigan.
Oh, Michigan.
Yep.
I have a sister-in-law that still lives there. I don't know why.
Trying to stay away from you.
Uh, well, it's kind of beautiful country.
It is.
In the summertime.
Yeah. They haven't been there in a few years, but they
Yeah,
have.
I'm from northern Michigan, so we're actually a little closer to northern Wisconsin and Canada than I am lower Michigan.
Oh, okay. At least she's closer to Detroit.
Yep,
They have the worst roads of any state in the country.
that's right. That's accurate.
I mean, I thought that it was going to shake my car to pieces.
Exactly.
Okay, well, we probably don't need to be recording all of this. You got any questions about anything today?
Nope, good to go. Appreciate your time today, Robert.
So next week we'll talk about digital circuits and components and microprocessors, and maybe have some demos.
Okay.
And that will be it until the technician starts on the 27th.
Gotcha. All right. Well, you enjoy the rest of your day.
Have you found any clubs around you?
No, I've reached out there's one club here in Panama City. But I reached out to someone via email. I've not heard back from him yet.
Yeah, it would help to go to some of the local club meetings, and
Yep, definitely.
there's probably some people there that would be helpful.
Yep.
You might find some that are less than helpful. Who knows?
Yeah.
Clubs are a mix of a lot of different people. There's always one that wants to show you he's smarter than everybody in the room.
Exactly.
And some are just grouchy. But
Some are even sober.
are what?
Some
So Okay. All right, I'm going to stop sharing and end. Unless you have any more questions.